In this video we're going to take a look at different kinds of Angular tests errors and how to debug them. By default, Angular tests run by a tool called Karma. Karma is a test runner developed by the Angular team at Google. It is responsible for spawning a browser and running your Jasmine tests. By default, Karma runs tests in watch mode. Karma keeps the process and browser open, waiting for changes in the code. If the code changes, it reruns the tests. In this case we had a console log, save, and our tests run automatically. Here's that log. You can turn this behavior off with the --watch false option. As you can see, the tests now run and the process ends. If you use npm scripts, remember to add an extra pair of dashes between your script and the options passed to the ng command. Why would we use this option? Well, there are some errors that don't show up when you run the tests in watch mode, but they do when you run the tests as part of your CI process. For this demo we just introduced a bug in a component, but it doesn't show up when we run the tests in watch mode, the default option. Let's run the tests again with watch mode set to false. We get an error we didn't see when we ran the tests in watch mode. Let's track down this error. It says it's coming from the hero search component, and the test starts with an empty list. Let's go to that spec file. This is the test. It uses detect changes to update the UI. Then queries for the link elements. And finally checks there are none. There's so little going on here, it's probably in a startup routine. There are other tests in here which didn't break, so it's probably not in the constructor. Maybe in an ng on init or ng on destroy. Let's check the component. As expected, the constructor doesn't have anything. There's something on the init. It's using the property search terms, which is an observable. For the contents of onInit to execute, the search method needs to run. So nothing on the constructor, and the onInit depends on another method. Nothing stands out. Let's go back to the test file and see if there's anything in there. The test itself doesn't call the search method. Up the chain, we have the before each, which only instantiates the component. Maybe we're barking up the wrong tree. Let's take a different approach to this. What if the reporter is wrong, and this test isn't the one which really threw the error? We're going to have to add some Karma reporters to get more information. Let's install the Karma Mocha reporter and the Karma Spec reporter. To configure these reporters, we go to the Karma config file. In here we look for the plugins section and require our reporters. We then go to the reporters property of the configuration and add Mocha and Spec. Now let's run the tests again using the flag, watch mode, set to false. We need to scroll up a bit to see the error. And now we get a possible suspect, the messages component. We look in the call stack and we see something called a base class, inside the messages folder, is throwing the error. If we go to the messages component file, we see that it extends base class. We open base class and we finally see the culprit of our error. We previously said the messages component was a possible suspect, because the error itself happened in the after all section. Error was thrown in after all. Errors are notoriously hard to debug, because the error happens asynchronously after the culprit succeeds. Let's put a delay before throwing the error to see what we get. We now see that the error supposedly occurred in the hero search component. If we scroll up we see the real culprit of the error, with all its tests passing. The moral of the story is that sometimes, you need to scroll up to investigate where the error originated. Now let's move to another type of error. Suppose you make some changes. Add some tests. Run your test suite, and everything is okay. You then submit your changes to your CI process. But to your surprise the tests fail on CI. You reset your local branch to match the one on CI. Run the tests again and they pass. At this point you begin to question your choices in life. What do you do now? To debug this issue you need to understand how Jasmine executes the tests. Let's open a test file. Add some console logs to these tests. And run the tests. Notice how the tests run in random order. We get B, C, D, A. If we update the last test and then save, we get a different output, this time C, B, D, A. This behavior is a good thing. Tests shouldn't depend on the order they're run. Knowing this, we can guess the likely cause of the error running on CI. There's probably a test that depends on the order in which the tests run. The error in the test report should tell you where the error is coming from, but sometimes it's hard to figure out why it happens without debugging the sequence of events that lead to the error. To run the same sequence of events twice, we have to use a Jasmine seed. For this demo we introduced an error in a test which depends on the order the tests are run. Let's run the tests. The tests pass, but let's run them again. This time they fail. In this case it's obvious where the error is, but let's pretend it's a difficult error to debug, and we need to debug the sequence of events that leads to this error. Let's go to the Karma config file. On the client section there's an entry for Jasmine options. We can add an entry for the seed Jasmine will use when randomizing the tests. If we set it to a static value, the tests will always run in a specific order. What we want to do is generate a random seed for Jasmine and output the value to the console for the developer to use later on. So if we run the tests, we now get the seed number which Jasmine used to randomize the tests. If we wanted to rerun this sequence of tests, we could modify the Karma config file, but that will get tedious pretty quick. It's better to catch the seed from an environment variable. Let's take the seed from an environment variable, and if it's not there, we'll use a random one. What we need to do now is run the tests until we get the error. This is the seed we need to get. Once we do, we put the seed in the environment variable. And now we can reproduce the error at will. This should make debugging the issue a lot easier. Let's move to another kind of problem. Sometimes errors are reported as warnings and thus pass your gate checks. Here's an example of these errors which don't fail the test suite. I'm sure your team would never check in code in this state, but just in case, let's make Jasmine fail the suite on these errors, which are reported as warnings. For this we need to go to the file which boots the test module. It's usually in the root of the source folder, and it's typically called test.ts or boottest.ts. In here we'll add a custom Jasmine reporter that will fail the test suite if any errors are thrown. Remember that we're getting an error on the console, but it's somehow ending up as a warning. So we're going to decorate the console error method with a custom one. It will fail the test suite if there are any errors. We run the tests again. And now they fail. The same technique can be applied to warnings. As a general rule, it's best not to ignore warnings and treat them as errors. To do that we decorate the warn function, just like we did with the error one. Now let's fix this error. We need to scroll up to see what's happening. It says App Hero Search is not a known element. If App Hero Search is an Angular component, then verify that it is part of this module. This usually means we forgot to declare a component in the testing module. It says the error is in the dashboard component, so let's go to that template. In the HTML we see it's trying to use App Hero Search. We have two choices now. We could make the test ignore the component, or we could start adding dependencies to our test module. The question is, do you need that subcomponent to test the current one? In this case, do we need to render Hero Search in order to test the dashboard? In most cases, including this one, it's not the job of the parent component to test the child. Testing the interactions between components is better suited for end-to-end tests. In this case we're going to assume that the Hero Search component is properly tested, and that we have end-to-end tests to verify the components work together. To ignore child components, we add the no errors schema to the test module. If we run the tests again, we don't get the child errors. Here's a general guideline. You probably want to use no error schema as soon as you see yourself declaring subcomponents, adding providers, and stubbing dependencies, which have nothing to do with the component you're trying to test. You don't want to use no error schema when you have shallow, control-like components that are integral to the behavior of the component you want to test. That's all for now. If you found this video helpful, check out the SimonTest extension for VSCode. It takes care of the most tedious part of testing components and services, stubbing dependencies. SimonTest analyzes your code and creates the necessary stubs, configures the TestBed, and it even generates basic tests. Search for SimonTest on VSCode extensions. Ask your company about getting a license for you and your team.